welcome back everybody. Today I'd like to talk a little bit about arrays, lists, and dictionaries. Three very somewhat similar items, types. They're all collections of some sort of object or type. Let's start off with arrays. They're the simplest one to talk about. They're basically one of the most basic ones that you'll encounter. The reason you might want to use an array, arrays and lists are very similar. One of the primary differences and reasons why I use one over the other is that an array is a set size. When you create the array, you tell it what size you want it to be. Like it might be 3 elements long or 3 elements large. A list can grow and shrink in size, and it's able to dynamically take care of that. If I know beforehand how large the array is going to be, or the collection is going to be, I use an array. If I do not know beforehand, for example, if there's a for each loop that might go a certain X amount of times, but beforehand I don't know, then I'm going to use a list to store those things. And so let's look at an example here. An array. Let's look at. Whoops. Let's create a class here first. Let's just call it test array. And let's create an integer array. Let's go like this. We'll do the longhand way first, and then later I'll show you in a second here I'll show you the shorthand way. So this is the longhand. We're creating an integer array. The brackets designate that it's an array. And we give it the variable just like before. We always tell what type of variable it is. So it's the type first, the variable, and then on the right hand side we're creating the object. So over here we create the object and we give a reference to that object, so iArray knows where to get it. So iArray is not the object, it just knows where to get it. Just like all the other object creations that we talked about previously. Let's give this a size of 2. And now we can add to that array. And let's just do that in the constructor here. So if we say iArray, we can access whatever element of that by giving it the index, and we stick the index inside of these brackets. And let's just give this a 2, and let's go iArray first element is equal to 5. So the length of the array is only size 2. If we decide to put another one in there, break. And let's go ahead and do that and show you. We'll create, what is it we call it, test array. New test array, and since this is all happening in the constructor, right here, it's going to break immediately. In fact, it might even not let us compile it. I've never written code like this, so we'll find out and see if this breaks it instantly. Oh, actually, it will compile because we haven't clicked the button yet. It happens in the button click. So we click the button, and sure enough, it throws an error. Index out of range was unhandled. So it tried to stick something into that third position. You got to kind of realize that arrays are zero-based, as are most things in programming, or zero-based. The same with arrays. So it's zero-based. So we fill the first 2 slots, and that's all there is. There's only 2 slots. It's only of size 2. It might look a little bit confusing because of this right here, but there's only 2 slots. We try to fill the third one in, and it says it was outside of the bounds of the array. The array was not large enough to handle it. So that's what you end up running into with arrays, which can be a hassle. But if you know beforehand the size of it, and it only needs to be a certain size, you go ahead and use this one. And I do believe it is faster than creating a list, because there's a little bit of overhead with lists that arrays don't have. So that's kind of why you would use one over the other. Now if we do list, we basically just use the list keyword. We have these angle brackets, and the cool thing with a list that a list is an object, a class, which can accept any sort of type. So you tell it what type you want to accept. So it's an integer list. Let's just call it iList equals new list. So we create the object here. And if we want to assign to it, we do it in the same fashion. Except for, you might be wondering, well, how do you know what, if you're going through a loop, you might not know where you're at on that list. You might not know how many elements are already in there, and you don't have to count it, etc., etc. Lists also have a cool feature. They have something called an add method, and you can just tack something in there. So boom. We did not tell it beforehand the size of it because there's no size. It just grows as it needs to grow. I believe behind the scenes it might actually create a base size and then resize later on if it needs to. I don't know exactly, but I just know that it's dynamic. You can add whatever you want in there, which is really nice. So this basically gets chucked in at the next position it can be, which happens to be the second position. So if we wanted to just print this stuff out here, we could. And then we can just print it out here. Whoops. So that basically just tacks that in there. There's a quick way to do these arrays as well. If it's called initializing the array with values, or just pre-initialize array. So if we know of some values, we don't have to create them here. We can just go ahead and as we're creating the object, this is kind of the shorthand. We can go ahead and just toss them in there, and they'll be assigned to this array here. And then it automatically knows that the size is going to be 2, and it tosses the values in there. So it's much quicker than doing this line plus 2 more. So it's handy. Now that's arrays and lists. Dictionaries. Let's take a peek at what a dictionary will do here. If you think of a normal dictionary, you have basically some sort of keyword you're looking up, and then you have its value. Like you might have some sort of word like cat in there, and then the definition for cat is a furry little animal, whatever. It's very much the same with a dictionary in C#. You're going to have a key value pair, so you're going to have a set of 2 objects that are going to be related to each other, and you can pull from the dictionary by calling for one of those keys. The interesting thing with a dictionary is you can't have an overlap, because you can't have 2 of the same keys in that dictionary. So you wouldn't be able to have 2 cat entries into the dictionary because it wouldn't know which one to grab if you requested cat. So let's take a quick peek at what dictionary looks like. Spell it right here. Oops. Okay. So see, it's asking for a key value, and then it's going to ask for a value. So you can be any 2 types. We can just say string. It can even just be a straight up object if you want, but I'm just going to use some built-in types. I'm just going to say, let's just go string. And we'll call it a test dictionary, new dictionary. And if we come down here, the way that we assign to this, it's basically asking for a string here, because we told it that it's going to be a string. So we could say cat. And what it's going to expect on this side is it's going to expect a string, because it's a string-string pair. So it's going to assign to this cat key, it's going to assign furry animal. And you can just keep adding in values. You can say dog. Thanks a lot. and I'm kind of writing this as a normal dictionary would be written, but you can put, like I say, you can put any value in for the key, you can put any value in for the, any type in for the key, which is over here, and any type in for the value, which is over here. So this just happens to be a string and a string. As long as the type matches your signature that you've created for that dictionary, then it works just fine. And what you can do with this is kind of a interesting example, but anyway, you could, for example, if you had some sort of dog name string and you wanted to fill it in with something from your dictionary, you could just reference that dictionary and pass into it the name of your key that you're wanting to reference. So you pull the key out, and guess what's going to go in here? Well, the value that gets pulled out of here, which the value is this right here. And we're just going to go ahead and write that out. Oops. And let's see here. We'll go ahead and leave the other one in there. I'm going to run this. And we're going to see what our output is down here. Actually, this was not, so we cannot do this with, I just remember now, we cannot do this with lists because list gets added to this way, but you can reference them this way. Like you can get the value this way, but you cannot add the value that way unless it's already existing. But since we haven't added anything to the collection, then there is technically no element right there. So that is right. We cannot do that there. So I'll clean this up real quick. So, for example, what I was basically saying is, so if you added a value, whatever, then you could go ahead and set, because now that there's something in that first element of the array, you could go ahead and set something in there, because now it actually has some value, because up here we created it and it had no values in it. It was basically a blank collection. So before you can actually access and set a value, like what I was trying to do a second ago, you actually have to create a value first in there. Usually you don't add things to the collection this way. That's generally not what ends up happening. So, but if you wanted to kind of overwrite a value that you had in there, that's how you would do it, and that would put it in that position. Let's go ahead and fire this up again. Push that, and let's take a look at it. This is just showing that we're writing out what's in our array, and there's only two elements in our, in our list. The 64 overwrote the 2 that was in the first position, and the 5 just took up the next position, so you've got the 2 elements right there. And the next thing, we're looking at the dictionary. So we're basically seeing what this value is that we pulled out. And we could have easily just put that right here, but I just wanted to show that you're getting a string out of that dictionary key. And that's pretty much it for arrays, lists, and dictionaries. Just a short recap. Arrays and lists are very similar. When you know the size of what you want for your collection, use an array. When you do not know the size beforehand, use a list. Dictionary is slightly different. It's when you want to store 2 types and bind them together, so that when you call one of them, you're going to get the other one back in return. So a key value pair. So just think of that as a normal dictionary, and you'll be set. Okay, thanks for watching.